Talking about radians. So radians are just another way of talking about angle measures. Typically we use degrees, but in math, radians are a lot better to use. Kind of seems arbitrary and contrived now, but when you go to calculus, you'll see very clearly how radians are much simpler to work with mathematically.
Did you start recording?
I did, but I think it's just frozen. So let me cancel. Bring it back. Okay. It's good now. Okay, so radians, the simple conversion is that pi radians is 180 degrees. Or you could also think 2 pi radians is 360 degrees. And the reason for this is because radians kind of come from the fact that a circle's circumference is 2 pi times the radius, right? So when we think about angles, we always think about, for example, an angle measure here on a coordinate plane. I think you guys have seen this before. We would start at the positive x-axis, then move counterclockwise, and then move to the angle that we want, and this is the angle measure. So for example, this might be 45 degrees. Alternatively, right, 360 degrees, that would look something like this. So this is how we define angles on a coordinate plane. We always start at the positive x-axis, and then we move counterclockwise and until we hit our, what we call our terminal side. So initial side, terminal side. Okay, and it's always counterclockwise. So moving in the same direction as the quadrants increase, right? Because this is quadrant 1, quadrant 2, quadrant 3, quadrant 4, right? And we'll see this more when we go into unit circle. But for now, it's important for you guys to know how angles are drawn on a coordinate plane and that they go counterclockwise. But first, let's talk about how we can convert quickly between radians and degrees. So in general, the formula is when we go from degrees to radians, we want to multiply by pi over 180. And when we go from radians to degrees, we want to multiply by 180 over pi. Okay? A good way to remember this is just think the one you want to convert to is always going to be in the numerator. Okay? So if I wanted to convert to radians, I multiply by pi over 180 because the one that I want, right, the radians, that's in the numerator, the pi. Okay? But in practice, actually, it's this is kind of too slow usually because you guys need to be able to do these conversions, you know, faster than breathing, okay? Faster than breathing. So in reality, you're not going to be actually multiplying by pi over 180. You're going to have to use some more, you know, mental math tricks, and I'll show you guys how you can do that. So a good way to do that is by memorizing some key or important radian measures and memorizing what they are in degrees. So some things you should memorize. First of all, you should memorize that pi radians is 180 degrees. Super important to memorize. You should also memorize that pi over 2 is 90 degrees. You should also memorize that pi over 3 is 60 degrees. You should also memorize that pi over 4 is 45 degrees. And finally, you should memorize that pi over 6 is 30 degrees. Okay? And then once you have these memorized, because these are the most common multiples of radians. Hello? Leonidas, right? Your test here. Okay, and the reason why we want to memorize these are because they're the most common multiples of radians that we're going to encounter. Okay, we have these memorized? Yes? Thank you. Photographic memory. Okay, so for example, I'll show you guys. if we had, say, 150 degrees, and you were asked, what's this in radians? Well, you would just think, well, 150 is 5 times 30. And I know 30 degrees is pi over 6. So this is just going to be 5 pi over 6. Okay? So that's why memorizing those is super important. Alternatively, you could have thought, oh, 150 is 180 minus 30. And 180 minus 30 is just going to be pi minus pi over 6, which is also 5 pi over 6. Okay? Another example, maybe you were given 315 degrees. Well, 315, I don't know what that's a multiple of, but what I could do is, well, that's just 360 minus 45. And I know 360 is 2 pi, right? And 45 is just pi over 4, because I've memorized that. And so this is just going to be 7 pi over 4. Okay? That way, this needs to be something you can do in your head. Otherwise, you're going to, this unit is going to be very tedious for you. Okay? Any questions? Okay, let's do some practice. Please convert these to radians. First person to get them all gets a haichu. Hard to come up with these. Okay, I think that's enough. Has to be all correct. This is what your group quiz will look like. So. A little more than that, but kiwi haichu. Kiwi's really good. Anybody? 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 When you're done, you can just shout it out. You don't need to come up. You can just say it out. Okay, go.
7 pi over 6.
That's your first answer?
Oh, first answer. Okay. 11 pi over 6.
Okay.
Then 4 pi.
Okay.
2 pi over 3.
Okay.
3 pi over 4.
Okay.
7 pi over 6.
Okay.
3 pi over 2.
Okay.
Negative pi over 12.
Good.
5 pi over 3.
Yep.
4 pi over 3.
Mm-hmm.
9 pi over 4.
Yeah, it's good. Good. Kiwi haichu. Okay. So, but were there any questions about any of these? I assume it's not too bad, just hard to do quickly. Right, 210, 7 times 30. 270 is 3 times 90.
What's 15?
15 is negative 30 degrees over 2. 300, you could do 5 times 6, 60, I guess. 240, 4 times 60. 405 is probably the harder one, right? That's 360 plus 45. Okay, so based on these, you can pretty quickly identify what these are in radians. 11 pi over 6, 4 pi, 2 pi over 3, 3 pi over 4. There you could check your answers. 7 pi over 6, 3 pi over 2, negative pi over 12, right? Because that's 1/2 of pi over 6, 1/2 of negative pi over 6. This is 5 pi over 3. This is 4 pi over 3. And this is 9 pi over 4. Okay. Next set is going to be converting radians to degrees. Very similar process. Just memorize those common angles. Let's do... Please do these. In your head, if possible. Well, we already know that, I guess. Oh, that's a harder one. I'll keep writing this. Key lime pie, haichu. It really tastes kind of pie-y, surprisingly. I don't know how they do it. Oh, I found another pina colada. That was a rare one. Yeah, I don't know either. Pina colada. What is pina colada anyways? Is it an alcoholic drink? Let me search it up. It is alcoholic, rum-based, right? I wonder if the haichu has rum in it. Well, I don't drink. Anybody? Okay, let's hear it.
210, 405, 75 degrees, negative 1440 degrees, negative 495 degrees, 660 degrees.
Sorry, I kind of stopped listening after the 75. Could you repeat those?
210 degrees.
Starting from negative 8 pi.
Negative 1440 degrees.
Negative 1440? Okay, yeah.
Negative 495 degrees.
Okay.
660 degrees.
660, yeah.
390 degrees.
Yeah.
420 degrees.
Okay, good. Pina colada.
See what it looks like?
Yeah. Okay, so just make sure you know how to do these for your group quiz. Let me write them in so you can check your answers.
Wait, is it 144? Wait, is it 140?
Sorry.
Oh, that's good. Wow.
Yeah. It's the apple.
It tastes like a pina colada.
No, it doesn't. I hear
How do you know what pina colada tastes like?
They make non-alcoholic versions.
Oh, they do? Okay. Just checking.
Oh, is it alcoholic?
Yeah. That doesn't taste like it. Don't worry.
All right, are we all good with degrees and radians?
Yeah.
Okay, 100% on the quiz. I'm excited to see that.
No.
Next topic we need to briefly cover is right triangle trigonometry. Also a lot of review. Ruhan. Quiet. Okay, right triangle trig. So we just need to briefly review sine, cosine, and tangent. The lovely trigonometric functions. You guys all remember SOHCAHTOA. If we have a right triangle and one of the angles is theta, you guys all know how to write theta, right? You write it like this. Don't write it like this in two strokes. You look stupid when you do that. Okay?
Hey, how do you write it?
You write it in one single stroke like this. That's exaggerated. Has to be skinny too. Okay, theta. If this is our adjacent side, and this is our opposite side, and this is our hypotenuse, then sine theta is equal to the opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse, and tangent theta is equal to opposite over adjacent. And this is memorized using our mnemonic SOHCAHTOA, right? SOHCAHTOA. Got it? Okay, alongside this, you need to memorize some key or two key triangles. This needs to be ingrained into your soul. If you don't have it ingrained into your soul, then you will fail every single test this unit. The first is the, I'll do it a little bigger. First is the 30, 60, 90 triangle. It's a bit exaggerated. It's not that small, not that skinny. Let's draw better. Okay, 30 degrees, sorry. How many radians is 30?
Over 6.
Very good. How many radians is 60? Thank you. Okay, so you need to remember the smallest side is always the opposite, the 30 degrees, and then the one that's opposite the 60 degrees is root 3, and then the hypotenuse is 2. Okay? So you need to memorize these ratios. Okay, have these ratios memorized. And then the second important triangle is the 45, 45, 90 triangle. 45 degrees is pi over 4 radians. This one's isosceles, so it's easy to remember. 1, 1, root 2. Okay? And so you need to have these side ratios memorized. So for example, if I were to have a triangle that was like, this is 30 degrees, and maybe this is like 1, then this side would be 1/2, and this side would be root 3 over 2. Similarly, for this one, if it's 45, if this was 1, then this would be root 2 over 2, and this would be root 2 over 2. Okay? So you guys really need to know this by heart. Any questions here? Then, okay, also sometimes on the homework you might encounter some triangles that aren't these two, but they'll be easy to solve using the Pythagorean theorem. So like 3, 4, 5 triangles, 5, 12, 13, 8, 15, 17. Anybody know any others? 9, 40, 41. That's all I know from memory.
You don't know more than that?
Do you know more?
But you're like the teacher. You not know more.
Let me think. Yeah, nothing really comes to mind.
How about 18, 80, 82?
That's the same. That's a trivial variation.
But I mean, it is a different one.
Yeah, it's not meaningful. Okay, so let's go over how we find sine, cosine, and tangent of these important angles. That will be the second part of the group quiz. So for example, if we were asked, oh, what is sine of 30? Question mark. Then we would have to draw our 30, 60, 90 triangle. Boys, quiet, please. 60 degrees. All right, so we would have 2, 1, root 3. Okay, make sure you never mix up the root 3 and the 1, okay? The root 3 is always the bigger side. That's opposite the 60-degree one. Can anybody approximate root 3? It's an important approximation to know. 0.7. 1.73. Okay, so that's bigger than 1, right? So remember the longer side is always the root 3. Okay, so what is sine 30? It's going to be the opposite, right? The opposite, which is the 1, over the hypotenuse, which is the 2. So that's just 1/2. Okay, next one I'll have you guys do by yourselves. Please do tangent of 45 degrees. Okay, tangent 45 degrees is going to be 1, because when we draw our 45, 45, 90 triangle, we have 1 here and 1 here. So opposite over adjacent, right, towa, it's going to be 1 over 1. Okay. Final thing I need to talk about, 3 additional trigonometric functions, cosecant, secant, and tangent. You know, some people will define those in terms of the, like hypotenuse over opposite. But for me, I think it's easiest to just remember that they are reciprocals of the other functions. So cosecant is the reciprocal of sine. Okay, these are things you need to memorize. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. Okay, a way that I like to remember them is just by thinking, oh, it's the opposite of what I would expect. Cosecant starts with a C, so it's the reciprocal of not cosine, but sine. Secant starts with the S, so it's not the reciprocal of cosine, but not the reciprocal of sine, but the reciprocal of cosine. I don't know if that makes sense. Cosecant is hypotenuse over opposite, yeah. Because sine is opposite over hypotenuse. Okay, you could memorize it like that. I find this more straightforward for me to keep in my mind. And that's what I've been doing for the better half of a decade. So, any questions about this? Your group quiz is going to be, I think, 10 questions on converting radians and degrees, and then 10 questions on finding sine, cosine, tangent, cosecant, secant, and cotangent of 30, 45, and 60 degrees. 10 of those. And I might have them written as radians. So it might be pi over 6, pi over 4, pi over 3. But it's just 3 angles. It's not that hard. I'll determine later. I'll see how fast the 1A does it and make you guys do something similar. Because you guys need to be able to do it very quickly, okay? Okay, final thing I forgot to go over is a question on the homework. It's going to ask you about something called coterminal angles. And that's really just asking about this, okay? So basically, when we have our coordinate plane, you know, sometimes we might have an angle that looks like this, maybe like a 45-degree angle, and it's going to look like that. A coterminal angle is basically an angle with a different measure, but it has the same terminal side. So for example, something like this, right? That would be 405 degrees. And it's different, it's way bigger, but it still ends on the same line. So we call it coterminal, okay? This is also a coterminal angle. Negative 315 degrees is also coterminal, okay? And so in order to find coterminal angles, all you do is add by 360. So 405, or you subtract by 360. Right, that's kind of the equivalent of going 2 pi, another rotation around the circle, or going backwards, right? Yeah? Yeah. Okay, so these would be two coterminal angles. In radians, right, what would this be? Pi over 4 plus 2 pi, which is 9 pi over 4, or pi over 4 minus 2 pi, which is negative 7 pi over 4. Okay? Any questions about anything? All right, let me pass back the tests.